Ever wondered how Google, Netflix, or Spotify deploy new features onto their applications without any glitch? Yes, you heard it correct. Kubernetes is a secret sauce. Hi everyone, this is Suraj Singh Rajput, and I'm passionate about making DevOps as well as cloud native concepts simple, practical, and accessible to everyone. Before we try to understand what is Kubernetes, let's try to understand what problem Kubernetes is trying to solve. And for that, let's try to understand with a particular scenario. Yeah, here's the scenario. So let's try to understand what problem Kubernetes is trying to solve in this real world. Now, for this, let me consider this particular example. I have taken a scenario of today is Flipkart Big Billion Day, and for that, this is my backend architecture. I have got one load balancer as well as 4 servers. Typically, on a daily basis, right, Flipkart receives 1000 requests per hour. Of course, this is an hypothetical scenario. Flipkart receives much more requests than this one. But so, like I said, this is just a hypothetical scenario. Now, in this case, this backend of Flipkart is able to handle only 1000 requests per hour. But if this number goes beyond 1000, let's say for example, and we all know that during Flipkart Big Billion Day, the number of customers who accesses Flipkart will increase 4 or 5 folds. So let's consider in this way, you are gonna get 1 million requests on this particular day. Do you think only these many servers can handle these things? No, they can't handle. So eventually these servers will crash. So one by one they will start to crash, and so Flipkart won't be able to take up the load. Just imagine you in the middle of the night or in the middle of the sale waking up and trying to solve the server crash issues. That's not going to happen. Even though you somehow try to fix this manual servers, so once again this scenarios will repeat, and once again you need to keep on solving these issues. For this, let's consider what if Flipkart is using Kubernetes in this backend. So generally what they do is the Flipkart application will be packed as a single application, like it has been shown here. It will be packed as a single application, and we call it as containerize it, right? And Kubernetes will automatically deploy new containers as traffic increases and scaling up in real time. Of course, what does it mean? So this is what it happens here. Imagine you started with 2 containers. We just started with 2 containers as well as 2. And when the load started to increase, Kubernetes will automatically detect the increase in load, and he will automatically create one more container to deal with this thing. Or not only one more container, this again depends on what is the current load and how many new containers are required to maintain that particular load well within below limits. Now, this phenomena where Kubernetes automatically detects and increases the number of containers to handle the incoming traffic is called as auto scaling, or scale out we call it as. Yeah. And after this, just imagine, so your Flipkart Big Billion Day sale has been completed and automatically traffic drops. During this particular time, there is no need for Kubernetes to maintain multiple containers beyond the necessary. So what they do is, or what Kubernetes does is, it will calculate the load. Depending on that, he will keep on reducing the number of containers, and he will maintain only those many containers which are necessary during that particular peak hours. Once we understood what problem Kubernetes is trying to solve, so now let's define what Kubernetes is. So people, as you can see here, Kubernetes is a container orchestration platform. That is what the definition has been given to us. And it has been designed to automate deploying, scaling and managing containerized applications. So let's try to understand what it is. So here, as we saw just now, one problem Kubernetes is trying to solve, that is automating the deployment of applications. That is what we call it as rollout or rolling out an applications. And secondly, we saw how Kubernetes automatically will scale out number of containers as and when required according to the load, and when the load drops, automatically the number of containers will be rolled back, or the number of containers will be reduced to match the exact load, right? So these are some of the advantages, these are some of the options that makes Kubernetes so special. Alright people, let's try to understand a little bit history of Kubernetes. Yeah. So Kubernetes originally started as a pet project of a Google, and so the initial name of this Kubernetes the initial name of Kubernetes is a Borg, and in 2016 Kubernetes become CNCF part, that is Cloud Native Computing Foundations part, and from then onwards it has an open source tag. The name Kubernetes comes from a Greek word called as helmsman or a pilot. The reason for that is, you can see the logo of a Kubernetes which looks like exact the wheel. So symbolically they are representing he is the captain of the ship. Alright people, let's dive into module 2, where we will understand how the Kubernetes works and what is the architecture of Kubernetes, what is master node, what is worker node, and what are the components that are involved in master as well as worker node, and we will try to understand in depth of each particular component, how it works there. Yeah. So as you see people, Kubernetes cluster consists of two basic components. One is control plane, another one is worker nodes, or control plane in other words is called as master node, which is responsible for managing overall cluster, and sometimes it is called as brain of Kubernetes also. And your master or your control plane has multiple components. Alright people, so let's try to understand what are the components that are present in your worker node and what are their functions. So first of all, here you can see there is a thing called as Kubelet. So Kubelet is responsible for maintaining your pods. If the pod has crashed out, or if there is some sort of wrong in the pod, Kubelet will inform this information to etcd, or the data will be sent to your etcd via Kube API server. Alright, now moving on to our next option. Moving on to the next component, that is pod. You can consider pod as a shell. which houses your containers. Now, your pod can have multiple containers or it can have a single container, and that is where your applications are running inside the pod, and that too inside a container your applications will be running there. Correct? Yes. All right, people. So lastly, let's just try to revise what are the components of Kubernetes of both master as well as worker node, and we'll try to understand, or we will try to revise this once again. So the first component is etcd, that is, or that stores all of your configuration files and all of our clusters data. That is one thing. Next one, scheduler is responsible for assigning pods inside a worker node by calculating the availability of resources. Then controller, so he is the one responsible for maintaining the number of pods, or he is the one responsible for maintaining the listed number of pods in a particular worker node, right? And Kube API server is the one who is responsible for, right? So making sure the communication happens between a scheduler, controller, as well as etcd, and for that matter, exposing any services to outside world, even that thing is also taken care by your Kube API server. All right. Now, coming back to worker node components, where we have Kubelet, he is tasked with monitoring your pods, and what is, if the pod goes down for any of the reasons, so he needs to inform this information to etcd via API server, right? And he is the one who will be maintaining your pods, right? And what is a pod here? Pod is a smallest unit of a Kubernetes component, and he is the one who houses, or you can consider Kubernetes pod as shell that contains all of your containers, right? And that is where your applications will also be running them, right? And now coming back to one of the last component, that is Kube-proxy. Kube-proxy is nothing but, he provides networking capabilities inside your Kubernetes cluster, or for that matter inside your Kubernetes pod, or for that matter inside your Kubernetes worker node. Hope you people are clear with this particular option. And there is one more thing that is left. As you can see here, there is a thing called as kubectl, right? So you can consider this as an external tool in the Kubernetes that is helpful, or that helps us to interact with the cluster. For example, just imagine you have written a manifest file, a Kubernetes manifest file, to create multiple pods on the worker node, right? So user will interact with the master, via kubectl to execute this manifest file. So for example, in the manifest file, the user might have written, I want to create 2 pods, right? By using kubectl, or with the help of kubectl, user will execute this manifest file, and automatically this manifest file will be executed in the master, and scheduler will read these things, and he will help us to create pods inside your worker. Of course, so he will take a help of API also, Kube API server, along with your controller also. Yeah. All right, people, as I explained, Kube API server, so it is called as entry point of all the API calls. That's what I said. If you want to interact with your controller or scheduler, or for that matter with etcd, or with any components of Kubernetes, we will take a help of what? APS server or Kube APS server. And next, like I explained, it exposes all the Kubernetes APIs over HTTPS or to the outside world. Right. So this is what I discussed earlier. Now, next option, etcd. So it is a distributed key value store, used for storing cluster data, configuration and state file. Right, that is what I discussed in other option, and offers high availability and reliability in that means 24/7, or as long as Kubernetes is running, this etcd will be present in the backend running. And like I discussed, Kube scheduler, it assigns the pod to a specific node based on resource availability and constraints. So like I said, scheduler will first check the worker node for the availability of resource, how many or what is the availability of RAM there, or what is the availability of storage options and all. Based on that only, Kube scheduler will schedule the pod creation in that particular worker node. Now coming back to Kube controller manager, like I said, that handles routine tasks such as responding to node failures, failure nodes or pod failures, maintaining right number of replicas in the sense maintaining right number of pods or state of pod particularly. Now this is an optional. So just imagine you are running Kubernetes on a cloud platform. During that particular time, what we do is we come across cloud control manager that integrates cluster with cloud service provider, right? So if you are installing Kubernetes on the local system, you don't need to worry about this particular thing. If you're using a services like EKS, right, and AKS or GKE, so then this thing will come into picture. Yeah, people. Now, coming back to worker nodes. So like we discussed, Kubelet, it is a primary agent that runs on node, or like I said, this Kubelet component will be running on each and every worker node, and he makes sure pod specifications are running and healthy. That's what I said. So he is the one responsible for making sure pod is up and running, and if anything goes wrong inside a pod, he immediately informs the same thing to whom? Your Kubernetes or etcd. Right, and Kube-proxy that maintains the network and enables the pod to have communication outside the cluster. Yeah, that is one time. And generally for container runtime, we will go with Docker. Docker will be installed as a base thing on top of which your Kubernetes will be running there. So most of you might be wondering, why am I using Minikube? See, by using Minikube, we can set up a local cluster, which is very useful for testing as well as learning. Since we are in a learning mode, it is better to use Minikube compared to kubeadm. Of course, we will deep dive into kubeadm also right after this one. So for my third module, I'm going to go and I'm going to launch a server. I'm going to launch a server in AWS, and as you can see here, I have chosen or I have launched the server of Kubernetes by using a T2 medium instance type as well as with 20 GB of hard disk space, or else you can consider in this way. So you need to have or you need to use T3 medium or T2 medium of instance type, and you can use Ubuntu 24 version of a Linux operating system. So, as you can see people, for this setup, I have chosen Ubuntu server on T3 medium or T2 medium, anyone works, and do make sure your hard disk is of 20 gigabytes size. Yeah. So as you can see here, I have already chosen this, or I have already launched this server, and I have already taken the connectivity. I have already taken SSH connectivity into my Ubuntu server. So now the first step here is I will be installing Docker first, and then I'm going to go and install Minikube, then I'm going to go and install kubectl. So let's check one by one how to do the installations. So for that purpose, let me go to my Google. There I'll search Google. So for installation of Docker on my Ubuntu server, so let me go to Google. There I'll try to search for Docker, and I'll go to the official Ubuntu on Docker repositories. Then I'll try to install that one. As you can see, my first search were install Docker engine on Ubuntu. Let me go on that one. As you scroll down, you will see a method called as install using apt repository. I'm going to go and I'm going to add my Docker repository in my Ubuntu server. Then I will try to install all the things onto my Ubuntu. So let's go and check it, how it works for us. I'm going to just go and copy this entire stuff and enter into my Ubuntu server, which I have already taken SSH connectivity. I'll just dump those things there and hit enter. And once it has been updated and completed, you can go and check with the command, or you can just go through the next step, that is install Docker package. Go back to your SSH, then you just dump those things there and hit enter. He might ask you for permission. If he asks, just write Y and he'll try to install all the things. Once it is done, you can actually go back and check whether the Docker is installed or not by running docker ---- version commands. So don't forget to add sudo. Yeah, as you can see here, people, the Docker version 28 has already been installed. So the next component, or the next thing that I'm going to install in my server is, I'm going to go and search for Minikube, and I'll try to install that particular Minikube there. For that, let me go to my Google once again. There I'll search for Minikube, just Minikube. He will take me to official website of Minikube. Let me enter there, and as you can see here, Minikube is a local Kubernetes. That is what our intention is. We're trying to create local Kubernetes cluster, and as you can see here, I will be needing 2 CPUs or more than 2, and 2 gigabytes of memory is compulsory, and 20 gigabytes of hard disk space. That's what I described in the beginning, and I have chosen the same options. Now, when it comes to installation, let me choose Linux, and I'm going to go with binary download packages. I'll just copy this entire stuff, which says he will install Minikube on my system. Then I'll go back to my Minikube. I'll just dump those things there. Hit enter. Yep, I guess my Minikube has been installed. We'll check that one also. But before this, once the Minikube has been installed, I need to do something called as Minikube start. That will start, or that will create a cluster right now. For that, as I copied this command, let me go there and let me just put on Minikube cluster. Let's check what error he throws. Yeah. As you can see, people, he's giving me particular suggestion. The suggestion says that Docker group. So this particular user doesn't have permission to execute these commands. So he's suggesting me to add this user to a Docker group. As you can see, I've done the same thing, hit enter. Then I'll try to run the command minikube start. As you can see, people, it started to download Kubernetes version 1.3 right now on my system. And like I described in the beginning, Kubernetes was a pet project of Google. As you can see, it is trying to download from Google's repository, GCR. We'll just wait until the download has been completed and we'll just go through how it creates a cluster and all. We'll just wait and check it. Yeah, I guess the download part is completed. People, as you can see here, he says currently it is consuming 2 CPUs and how much of memory? 2.2 gigabytes or 2.200 MB of RAM it is consuming. And you can see it is preparing Kubernetes version 1.33.1 on Docker. What is the version of Docker? 28.1.1. There it is trying to create your Kubernetes cluster. As you can see, so booting up control plane, he has created something called as control plane, and then he has come up with something called as RBAC rules. What is this? We do have a curriculum. There we will try to understand what is RBAC and how the roles changes. Everything we'll try to understand there. And as you can see, people, he says the installation of your Kubernetes is done. So let's check it. I'm going to check with the command. Yeah. As you can see, he says as soon as I check with the command minikube status, he clearly shows there is something called as control plane, there is API server running, kube configure running, multiple things are happening. But still on this way, I have not yet installed something called as Kubelet, right? So let's try to install that. Sorry. But still on this part, I have not installed something called as kubectl. So which is very, very crucial for interacting with your Kubernetes cluster. So let's move ahead and let's try to install this kubectl part right now. So for that, I have a command, or I will take a help of snap, right? So this is the command, sudo install so automatically Kubernetes or this kubectl, so automatically Ubuntu will download kubectl from its snap store and automatically it has installed also. As you can see there, kubectl is up and running, right? And let me run one simple command and let me show you. So whether it has created cluster, if the cluster is created, what is this cluster called as? We'll get to see some of the details. As you can see, people, these are the Kubernetes components which are up and running, and let me run a particular command which will give you complete details. So as you can see, he says no resources found in default namespace. Of course, we haven't yet created any pods, so that is the reason he says there are no such things right now. Alright people, so no issues, no worries. So we will try to understand how to write a manifest file, then we'll come back and we'll create a pods, and then from there we will continue forward. If this session has helped you learn about Kubernetes, do hit like, share and subscribe button for Star Ajay. I will meet you in the next video. Till then, keep learning.